Hello everyone, welcome to part 6 of CYPE series. And in the last part, so if you remember, so we talked about the different specifications, and also we talked about the offset, we talked about the releases, and also we talked about the physical members and also analytical members. So we said that analytical members can be seen in this form, and also the physical model members can be actually can be seen as highlighted black color. And also we said that during the analysis and design, so this highlighted black colors will be considered as one single member. Okay, so in this part we want to talk about the buckling options, and so after that we will go to run the analysis, and also we review the results of this let's say work. So let's go ahead with buckling and explain something about the buckling factors. So the most important thing and the key point about the buckling, so always we need to keep into our consideration that once you want to apply or assign the buckling factor or effective length to any member, so it means that you are actually you are not having the member in your model, but you want to see the effect of that member as a restrained member, for example, to other member. This as an example, so just for more clarification, as you can see here, I have the columns, and just assume that here for the column I have some gears here. For example, here I have the gears, and but right now I'm not actually modeling the gears, because just assume that I don't want to design this gears, but in reality and in the site, so I have this gears existed actually or let's say included in the model. So that's why here, so I need to specify the buckling factor or effective length to this column, because by default, so here if I go to bar, and then here just I want to see, okay, so the height of the column is 6 meters, and then so if you apply, for example, let's say any lateral load from here, so then the buckling shape of the column will be exactly like this. Okay, and it is actually if you look at the global coordinate system, so it is about the let's say x-axis, so which means it is about the y-axis. Okay, so here is y, and then so this buckling will occur exactly around the y-axis. So that's why if you add the gears here, okay, just assume that for example you have 6 gears, and then here the total length of this column is 6 meters. Okay, and after adding the gears, or let's say considering the effect of the gears, so here we can say that we have 1.5 meter each. Let's say here 1.5, 1.5 meter, 1.5, and then 1.5. Okay, so then I need to specify or assign or define the buckling factor or effective length. So in this example, so I'm going to assign the effective length to this column because it's easier. And also, I have some feedback from our followers. Some of them actually ask me about the buckling factor. So if I want to make it easy for you, so it's better actually to work on effective length, because as we know that there is a direct relation between buckling factor and effective length. So for example here, if I say that K is the buckling factor, so then here I have the LCR or LE, which is effective length, over R. Okay, so it is actually the relation between effective length and also between the buckling factor. As you can see, it is direct relation. And so for assigning the let's say restraint to the column in this particular example, so either you can go for adding the buckling factor, or you can go for let's say assign the effective length. So that's why here I'm going actually to assign the effective length here. It is easier to understand and also easier to assign. So that's why here I need to select all the columns that I have here, and already I group them. So that's why I select all the columns, and from here, so if I just clear everything, so here you can see all the columns are selected. And once again, since here I haven't modeled the gears, so that's why I want to go to assign the buckling factor or effective length. Otherwise, if you had the members here, so you don't need to go to assign the effective length, because already here you have the analytical node, okay, and the software automatically understand the let's say restraint and also the effect of gears, and it will be assigned by the software to the column. So you don't need to apply the buckling factor or effective length. But since here I'm not going to have the gears, so that's why I need to go to buckling factor, and then so I need to go to assign the effective length. For doing so, so after selecting the columns, then right click, go to bars, okay, and then here you have the buckling. You have the buckling option. Please select all the columns. So from here, simply I can go to here, and then maybe one of these views, for example here, so I can select these columns. So make sure that you select the correct members. Okay, for example here I have these braces also selected, so that's why I will go to another view and press shift, and again deselect this braces just by holding shift, and then simply you can deselect the braces. So right now I have all the columns selected, and then so right click. So here by default, so the software actually just use the buckling factor as 1, which means pin. Okay, so it is up to you. For example, here in our example here I have the let's say fixed support, and then here also is let's say another fixed support. That's why here you can also apply the fixed pin. For example, here you have the 0.7. Okay, but if you release, for example, if you have this column, and then here you release the for example this tie beam, and also you release, for example, this member and the rafter. So which means here you have the fixed pin. Okay, so here you need to go to fixed pin, and then here you have this one. Okay, but if there is not released, so which means here base of the column are fixed, and then here if there is no release for the tie beams and also other members connected to this node, so then maybe it's better to go to fixed a condition, which is here, which is 0.5. So it is about the buckling factor. Okay, but as I told you, so the easiest way is to go to assign the effective length. Okay, so here you have the option to assign the effective length. So I will click on this, and if you remember, so we said that we want to have the three number of gears here, and then each of them are 1.5 meter. Okay, so then simply I can go to this option, and then here I have the 1.5 meter. Okay, but another important thing, so we need to actually take into our consideration, which is the the proper plane or proper axis that this restraint is existing. So for example, here let me just close this before adding this effective length. So just I will close this, and let me just zoom in somewhere here. Okay, I will later again select the columns, but let me go back to here. Okay, so I want to look at this columns. Okay, as you can see here, I have a column like this. Okay, and inside, so here it is the x-axis. Okay, and then this is the y-axis, and this is the z-axis. Okay, so if I apply the, or let's say if I had the gears in this direction, okay, so which means the column is restrained, so in such a way like this. Okay, and this actually a curvature is around the z-axis. Okay, so it is about the z-axis. So if you have let's say some other members in maybe in this direction, so then the effective length that you need to apply, so it should be around the y-axis, because the restraint so is in this direction. Okay, so that's why here. But here, since we are talking about the gears, so definitely, so we need to take care about the z-axis. And if you look at the plane, so it is xz plane. Okay, so which means this restraint is actually happening in xz plane. So that's why I need to select the xz plane in the buckling option. So I will go back to select the columns once again. So let's go to buckling. So I will go to this view. So once you don't have the entire model, so you can use this option, so which is full window. Okay, and then from here, so you have it. So then I will go to again select all the columns just like this, and then go back here, press shift once again, and then deselect this braces. Okay, and then here I have all the columns selected, and then right click. So now here I will go to xz plane. So that's why here I have the xy plane, and here I have the xz plane. So I need to simply ignore xy plane. Okay, or from here simply you can just accept this one, the default one. Okay, and then so come to xz plane. So on the xz plane, so go to effective length factor or assign buckling length, and then here so you have the length, and I will put as 1.2 meter. Okay, and then accept. So that's it. So we applied the let's say effective length, and as we mentioned already, so there is a direct relation between effective length and buckling factor. So another important thing that you have actually inside, so is lateral buckling. Also, we can actually say that lateral torsional buckling. So how it works? So let's say here, if you want to have actually more accurate let's say consideration, so you need to come to this column again here. So you need to look at this column. Okay, and then if you go to lateral buckling option, if I just click on the column, so here I have two options. I have the top phalange, so which means I can restrain the top phalange, or I can restrain the bottom phalange, or sometimes you have actually the restraint at bottom phalange and top phalange. If you are working with the beams, okay, so it's easy, for example, or if you are working with the rafter, it's easy because you know that, for example, here it is the rafter, as you can see here, it is the rafter, and at the top of the rafter, so you have the let's say the purlins. Okay, so here if the rafters actually just continue like this, so at the top of the rafter, so we have the purlins. Okay, so here we have the purlins. So that's why simply you can come to top phalange. Okay, and then so you can just measure the space between the rafters, between the purlins, sorry, for example 1.2 meter, and then simply here you can again go to effective length. So here you have the option. Let me just delete this. Okay, and then here you have the option to apply the separation between bracing. So here you can put, for example, 1.2. But again, the important point is that since we have the Perlin here, so I don't need to come to here and then specify the value, because already the analytical modeling is there, the nodes are there, and that's why, so you don't need to come here and specify the let's say the buckling. So that's why, so simply I can leave it as default. Okay, but what about the columns? We said that here, for example, we have the gears. If I continue the column, so the column will be like this. Okay, so it is the, let's say, the continuation of the column. And definitely, the gears will be somewhere here. Just assume that here you have the C channel as the gears. Okay, and then, for example, the spacing between this gears is 1.5 meter. So then here, so how to understand that you need to assign the this restraint at the top flange or bottom flange. So how you should understand which one is the bottom flange and which one is the top flange. So if you look at the, again, local coordinate system that you have here. So here, this, let's say, axis is exactly parallel to the height of the column or section. So that's why here you can say that it is the start point of the axis, and here it is the end point of the axis. So that's why, so we can say that this one is the bottom plate, or let's say bottom flange, and here this is the top flange. Okay, so again, it's very easy to understand, not only for the beams, also for the columns. Simply you can understand which one is the bottom flange and which one is the top flange. So simply you can, let's say, apply the restraint, if you want to be more accurate, only at the top flange of this column, because the top flange is here, and then gears are attached to the top flange. Okay, so that's why here you need to come to here, then go to effective length, and then from here say that 1.5 meter. Okay, so since I don't have, well, let's say already I selected the buckling factor itself, so I'm not going actually now to apply this. Just I explain this for your general information. Okay, so it is for this, and after applying this, so here I have the let's say effective length for the columns as 1.2. Okay, so once again, so if I go to the buckling, so from here you can see that in XZ plane and around the minor axis, so I have the buckling factor as 1.2 meter. Sorry, effective length as 1.2 meter. So that's it. So we did it, and then so let's go to analysis part. So from here, I will go to run the analysis. Just simply click on here. So before running the analysis, also let me explain a bit about these three options that you have here. So the first one is, as you can see, do not dimension section. So what does it mean? It means that, for example, here you are working on a strengthening project. So which means the structure is existed, and so you recreated the structure having the existing sections. For example, here maybe you have the UV sections and all these let's say columns, just you recreated according to existing sections on the site. And then so here you need to select this option, which means you need to tell the software, do not change the section that I assigned to the members. Okay, so it is the thing. The second thing is the quick section design. So which means if you are working on the new structure and you want to come up with a proper sections, so you can go to quick section design, or you can go to optimum design, or let's say section design. Okay, so here you have these two options, and from here again you have two options. So either you can go to select the for example, if you assign for this column, let's say UC 305 by 97. Okay, if the column cannot carry out the load, okay, so then the software, you can tell the software to use the the same series, which is actually UC series, but actually the greater than 305 by 97. Okay, but if you come to the second option, so use all the sections of the series. So which means maybe the software apply the smaller sections with the bigger thickness, or the software just through the iteration, maybe it use bigger section with the smaller thickness of the flange or a web. So it is actually the concept of quick section design and optimum section design. So let's go ahead with do not dimension sections. So which means here I don't want to change the section. I want to keep my section that I assigned to the member, and then accept. So here you have actually again some reminder from the software that it tells us. So have you applied the buckling factor in XY plane or in XZ plane? How about the equivalent uniform moment factor? How about the lateral buckling at the top flange or bottom flange? So you need to take care of it. And always I recommend actually to have this dialog box. Okay, some of the users simply they check this option, and after running the analysis they cannot see this option anymore. So I recommend you to keep this one as default. So every time, at least the software tells us to or remind us to take care of about the effective length or buckling factors or lateral torsional buckling. So and then accept. So let's go ahead with this one. Okay, so here I have some, let's say, information. I'm saying, information, and this is, the first one is information about, having some error. So which means error have been found upon carry out the surface load distribution. And then, so if you want to see the errors or warnings, so always you can go to the analysis tab, and then you can activate the show or hide option. And the next one is the fire check option has not been activated. So it is very simple. And I know actually the reason for this because I didn't activate the fire resistant check. So I can ignore about this, but this one should be solved. So this error should be solved. So how we can solve this one? So I can close this one, and then so I will go to analysis, and from here I have show hide incidents. Okay, just click on this, and then from here, so I have actually some let's say warnings or errors, and if you put your cursor here, so it has not been possible to completely assign all surface load to the panel. So what we should do in this cases, so first of all, if I go to panel, so it is something related to load distribution option. So that's why here I will go to CD modify the distribution direction of the load. Okay, so here I have this. So please pay attention here, I have the purlins. Okay, and that's why here, so the distribution load is exactly, in the, let's say, rafter direction. So which means in this way, the rafters will be loaded. Okay, but since I have the purlins, and if you remember, also we offset the purlins, exactly at the top of the rafter. So that's why we need to change the direction of the load to this direction. And then so I need to load the rafters, load the purlins. So here I need to load the purlins. So it is actually, the fact that I need to do. So for doing so, again, so I need to go to load, and then here you have the modify the distribution direction of the load. Just click on this. So I will select this, let's say, panel. Okay, and then from here, so I will select this line to just modify the load distribution. And then also for this one, I will select this, and also I will select this one. As you can see right now, so the purlins are loaded. If you go to the load, okay, maybe I can show you just a visible load case. Maybe I can go to live load just to show you. And from here, so you can see that the purlins are loaded. Okay, if I zoom in, so right now you can see the purlins are loaded, and here the software automatically decompose the surface load to the member load, which is purlin load. Okay, so after doing this, so once again I will run the analysis to see still I have the error or not. Okay, so just accept. Okay, please bear with me. Okay, still I have this error, so let's go ahead. So right now I have here and here, but I don't have any error right now for this panel, which is already actually we modified the distribution of the load. So which means actually we are in the right path. So another thing that I have is this one, this panel and this panel. If you remember, this panel automatically has been created using portal frame generator. Okay, so which means here I know that this panel is related to wind load. So that's why again I will go to load, and then here modify the distribution direction of the load. But before going there, so let me show you something. If I go to edit surface load, okay, so here I want to go to edit surface load, and please pay attention to here. So if I go to, for example, look at the wind 0, okay, and then here, so I have the, let's say, the load which is applied to the columns, and then here to the rafters. So everything actually done automatically. But due to this, let's say, inclined surface, and then here, I have some other members. So it's not that simple for the software to decompose the surface load to the members. So that's why we are getting, this kind of error. So for doing this, so simply I can change the direction of the load in this manner. Okay, but I will show you also, there is no effect on these columns. Okay, so which means, the columns will take the load and you don't need to worry about it. So that's why I will go to load, and then here I have the modify the distribution direction of the load. And from here, so I will select this one, and then so you need to select this vertical reference line. Okay, so click on this, and then here I have this. So similarly here, I will go to this panel, select this one, and again select the vertical reference line. Select on this and this. Okay, once again I want to show you the effect of wind load to the columns. Okay, so because we cannot simply accept this, that's why I will go to edit surface load here. Okay, and again, as you can see, I'm under wind 0, and here you have the effect of the wind load on the columns. Okay, so it is actually the things that I wanted also to share with you. And once again, so I can go to analysis, and hopefully right now we don't have any error or warning. Okay, that's great. So right now already we solve the error, and I don't have any error. So the only error that is existed is the fire check option has not been activated. So it is up to me, and that's why I'm not caring about it. So close this, and now we can go to let's say talk about the analysis part as well. So the first thing is about the displacement. Okay, so I want to check, for example, the displacement of the members. But before going to the displacement, let's look at the overall condition of the structure that do we have, for example, any failed member or not. So for doing this, so I go to check elements, okay, and then just accept this. Okay, and then here, as you can see, so I have actually some failure for the braces, and also some of the purlins already, let's say, failed. So what can I do? If I go to, for example, select this purlin, okay, so this purlin is failed, and also this purlin. So if I click on here, so I can see that the compression axial force is excessive and exists the critical buckling axis forces. Okay, so what can I do? So simply I can click on this member, and from here the software gives me actually the different purlin sizes with different utilization ratio or resistance factor. Okay, so it is the beauty of CYPE3D, and I like this feature because I don't need to rerun the analysis again and again. So simply I can come to here and I can select or let's say check the section, because here I have the utilization ratio. For this one right now I'm using IPE 80, so that's why here I have the actually some failure due to compression axial force, and simply I can change it to IPE 140. So once I want to change this one to IPE 140, since already I group the purlins, okay, so all the purlins take this this section IPE 140. So, and it is again another advantage of grouping the members. So I will click on IPE 140, and right now I know that the utilization ratio by this analysis will be about 67%. Okay, but after changing the section, so once again we need to rerun the analysis to again redistribute the stiffness and also the forces. So that's why I will accept this. Okay, and right now, so here I can see that this member, this member actually is the bottom member. Okay, and but here you can see all of them are have been changed to IPE 140. Okay, so right now I have all of them, and here also I have this one. This is actually the purlins. As you can see here, it is at the top. So also I need to change the purlin, but here it is 101%. So again, it is based on the your engineering judgment. Sometimes, so you can actually agree with this condition, because already we have some let's say coefficient, and so if you want to be let's say in optimal level, so maybe you can accept it. Okay, but if you want to be in a conservative way, so that's why you can click on this option. Okay, and then so again the software tells you that instead of CF 102 by 3, so maybe you can use the 140 by 3. Okay, or here maybe you can use the 160 by 2, and then here you have the same utilization ratio. Or maybe you can come to here and check the, or let's say select this purlin. It is 160 by 2.5, and then it gives me let's say almost 80%. So I will select this one and then accept. So all of the purlins will be changed to 160 by 2.5. Okay, so just bear with me. Okay, and then as you can see here, all of the purlins just changed to 160 by 2.5. And right now if I zoom in, so all the purlins and let's say the bottom members are passed. The only members that I have are the let's say this braces. So if you want to design the braces, so again simply you can go to click on this option, and also you can let's say select another section that you have. For example, here maybe you can use, actually here I cannot use any of them because I have the utilization ratio more than 100%. But here, yeah, I can see here I have the this option maybe I can use, but also you need to check. So right now you are using the R25, or let's say 25 mm for let's say around the steel. Okay, so if you want to pass it, maybe you can use this one, this R65. So up to you, and then so you can accept it. So since again I already group the braces, so that's why most of them, or let's say all of them take this section. But here still I have this one which is a little bit more than 100%. So if I click on this, so maybe a bit I can increase this one maybe to this one, R70, and then accept. Okay, and still I have another member. So you have actually different options as a designer. So right now, for example, here you have this again a little bit more than 100%. Instead of changing the section, so maybe you can add more braces here. For example, here you can add more braces just like this. Okay, so it is up to you. Okay, if you want to have the precise design, so you can add it based on your experience in designing. Okay, but here I'm going actually to increase the size of the braces, but sometimes actually it won't be let's say an optimized section, because I'm going actually to take a very let's say thick section with a high diameter. So that's why. So again, so I will leave it to you. But as a designer, so as I told you, so you can go to add maybe some more braces. But for training purpose, so I will simply again go back to select this one. Maybe it is the last part, and then so from here I will select R80. Okay, and then accept. So now everything is passed. Okay, and again, so you need to rerun the analysis. Okay, so you need to rerun the analysis, and again, so if you have the any failure, so you need to take care of them. Okay, so here I'm waiting for finalizing the analysis. Okay, so we don't have any error, and then so if I go back here, so right now you can see, let me go to analysis, and then here check elements, accept, and then here so you have some other let's say members are failed. For example, here I can see the rafter so is failing, and it is actually about almost 100. So but again, so you can select this rafter. So right now the section that I'm using is 305 127 by 48. Okay, so maybe here you can use this one, and then so simply you can pass the analysis, or let's say pass the design. Okay, so let me do it, accept, and all the rafters will be changed to this section. Okay, and again, so please do not forget, so you need to rerun the analysis and then accept. So it is actually the process that you need to do for finalizing your design. And especially once you are working with the CYPE, the process is very easy, because the software actually gives you all the information related to utilization ratio, and simply you can select a proper section that you want to let's say assign to the members with the design passed. Okay, so maybe it is the last time that I'm running the analysis. After that, I will go to talk about the displacement and also forces, as well as the reactions on their different load combinations, and then so we can finalize this video. Okay, so I will close this and then go to analysis, and then again check elements, accept. Okay, so right now everything is passed, so great. So now we can go to other options. So please remember, for overall check of the structure, so you need to come to check elements. Okay, so it is the very important point. So then let's go to displacement. Assume that here I want to check the displacement of this, for example, tie beam. Okay, so first of all, here we have actually different type of loads. So right now I have the simple load case, and then under simple load case, as you can see here, you have the let's say primary loads. For example, I have the self-weight, roof load, solar panel load, live load, and also wind load. So another option that you have here, so is displacement. So displacement simply, which means SLS, or serviceability limit state, and from here the software automatically generate all the SLS load combination. So maybe I can come to the last option. Okay, and then under this, or you can from here you can go under envelope. Okay, but here, so under envelope I don't want to check the displacement, as we know. So for displacement, so we need to check it under let's say SLS. So that's why I will go back to select combination and then displacement, and from here so I have the last option, and then so I can go to click on this member. Okay, and then here it gives you actually the displacement at both nodes of the member, and the most important thing actually is the let's say this displacement. So I have the displacement in x direction, y direction, and z direction. So that's why you can see dx, dy, dz. Okay, and then here also you have the same thing. So if you want to look at the vertical displacement, so we need to look at the dz. Okay, so here, because here inside, so the for the node, even after running the analysis, so you have actually exactly the same coordinate system for the node as you have for the global coordinate system. That's why for the vertical displacement, so you need to look at the z-axis. That's why here in the z-axis, almost you have 0 millimeter, so which means the member is fine in terms of the deflection. But in terms of the let's say dy, so which means in this direction, since we have the wind load, and that's why this node is actually experiencing some movement in this direction. So maybe you need to check the displacement limit or deflection limit for the columns. Okay, so which means usually is about L over 180. Okay, so then you need to actually let's say consider this. But again, so if we say that here the height of the column is 6 meters, so simply we can say that 6,000, which is 6,000 mm over 180, and then so it gives you, if I calculate this, it gives you 33 almost. Okay, 33 mm. So which means actually this is far bigger than this 0.85. So which means also the deflection limit for the column is fine. So in this way you can also let's say check the displacement of the members. So let's go to another option. I will go to analysis, and then here I have the reaction. So for the reaction, again, here you have different options. As you can see, the first three options are selected combination. So, most of the time, again, so we consider the reaction under SLS. So that's why I can go to displacement, which is SLS. And then from here, so you can come to, let's say, the critical SLS combination. And then then simply click on the support. And then here you have the Rx, Ry, Rz, which means reaction in the X direction, the Y direction, and also in the Z direction. And also you have the moment around the X, Y, and Z axis. So another option that you have the foundation equilibrium combination envelope. So from here, so software automatically, take the envelope load, to design the foundation, or you can go to the last option again. So it is based on the bearing pressure combination envelope. Okay, so you can also see the let's say reaction according to bearing pressure. Okay, but since in CYPE you have actually the option for foundation design, as you can see here. So you have the foundation tab, and then simply you can go to the foundation design. So you have the foundation element like pad footing, combined footing, pile cap, and tie beams, strap beams. Simply you can design the foundation, and you don't need to worry about these two options, because the software automatically taken the loads into consideration, and according to this load the foundation will be designed. But if you want to let's say pass the foundation forces to another party, for example, another party wants to use another software, to design the foundation. So the recommendation is that you can come to selected combination, and then go to SLS, and from here select the worst case scenario, and then so from here simply you can click on this options, and you can just export the reactions under SLS to another let's say designer or foundation designer. So it is actually for reactions. And another option that you have here, it is forces. So simply also you can go to the forces. As you can see here, maybe you can go to the forces under, again, different load combination. So, but as we know, so for forces, we need to have the design forces, for example, design moment, design shear, and also design axial force. So, and this design forces should be done under ULS, ultimate limited state. So that's why here, so you need to select the ruled and built up section steel. So as you can see here, for let's say different load option that I have, the first one is simple load cases, which means the primary load. Displacement is SLS, or serviceability limited state, and then so the rest, all of them are ULS. So which means here ruled and built up section steel is actually ULS, cold formed steel is ULS, timber is ULS, aluminum is ULS, and concrete is ULS, according to different kind of properties that you have. Okay, for example, right now here we have the ruled steel. Okay, so which means we have the rafter, we have the columns, we have the let's say trusses. Okay, so the only thing that I have as a cold form, which is purlins. Okay, so that's why here also you can come to the cold form steel as well. But almost the load combination of the ruled hot ruled section and cold form section almost is same. So that's why you can go to ruled and built up section, and you can consider it as ULS, because the software actually does this for us. And then I will select this one, and then here you can see that you have the factory loads. Okay, and then maybe from here you can come to the worst case scenario. So from here I can go to the last one, for example, here. Okay, and then so I have this. Okay, and from here maybe I want to look at the for example moment. So inside, so the my, or moment around the y-axis, is the actually the critical moment. So which means that if I have the member like this, okay, so here it is the let's say x-axis. Okay, and then here it is the y-axis, and this is the z-axis. And then so here the y-axis actually is the major axis. Okay, and then z is the minor axis. So that's why you need to actually look at the major axis, which is my. Okay, so which means the deflection, or let's say the maximum moment, actually you can take it in this manner. So that's why here, unlike for example other software like StatPro, in StatPro if you want to look at the moment, so must let's say most of the time, so you need to look at the MZ, which is actually known as StatPro. The z-axis is the major axis, but here inside the y-axis is the major axis. So that's why here I will click on the my. Okay, and then here you can see the let's say the BMD, or bending moment diagram. Okay, for all the members. And if you want to scale it, so you can scale it, for example, from here I can scale it just like this. If you want to see the value, so here you can click on this, and then here you can see the value. Right now here actually the value cannot be adjusted, or for example you cannot increase the size of the values or decrease the size of the value. But we know that actually the self development team is working on this feature, and most probably in the next release hopefully we have this option as well. So which means simply you can adjust the text sizes. Okay, So it is actually, for moment, maybe you want to look at the shear again, for the shear, so you need to look at the shear Z. Okay, so here you have the let's say values. If you don't want to see the values, so here you can see the let's say shear. Again, you can scale it up or scale it down. Okay, and also you can look at the axial force. As you can see here, you have the axial force. If you want to see the let's say text, also you can see the values just like this. And another good thing about here CYPE3D, so you can go to select by sections. For example, here I want to see the axial force for this column. Okay, and then simply I can go to here, and you can see the axial force for this column, and simply you can actually make a decision for this column if you want to revise or modify anything here. Or you can look at the moment, and then here you can see the moment only for this member. Or I can also go to this one, and then here I have the moment for this section as well. So in this way also, again, you can check the options. Another good option that you have here, you have the consult values. For example, here I can click on this, and then here I want to look at the moment, for example, for this member, and just if you hover your cursor, so as you can see here by the location, so you will get the amount of the moment. For example, here at the 0.9 meter, so the moment is minus 17 kilonewton meter. So if I go to here at the let's say almost 3 meters, the moment is about 14 kilonewton meter. So it is can be done let's say under consult values. Okay, so it is about the forces, and also if I go to here, if you have any area objects, for example, wall or slabs, so you can go to this option, and you can see the deformation of the slabs and walls as well. But also here you can see the deformation of the entire structure, including the members. For example, here again, so you can see the deformation. Okay, and from here you can go under let's say different load combination. For example, here I will go to SLS, and then maybe I can go to the last one, the last option of the SLS. And from here also I have the option to look at the structure, for example, from this view. Okay, and also I can set the or see the the real structure just like this. A little bit I can increase the scale, for example, by 50, and then enter. So you have something like this. And after that, so you can go to animate the deflection. Okay, so as you can see here, you can animate the deflection. Also, again, you can come to this view, and as you can see here, you have the animation of the deformed shape. Okay, so then simply you can close this one. Okay, and also you can close this one as well. And another good thing here under deformed shape, so here again under forces you have the consult. Okay, so which means that again from here you can see actually the different options. For example, right now I'm looking at the SLS option. Okay, and then here you can see the displacement and at each member. Okay, so here you have it, and also here you have the overall displacement. Okay, having this legend. For example, here I can see that the displacement here it is about 28.5 meter. Okay, so which must probably actually occurring somewhere here. Okay, so it is about the deformed shape of the structure, and so finally you can go to let's say see the step-by-step design calculation report. So here it is the option. You can go to ULS check. Okay, and then from here, for example, if you want to see the step-by-step calculation report for the design of the column, so simply you can click on this column, and then here you have all the step-by-step calculation report for designing this column. So if you want to see it in single PDF file, so here you have the option view the complete listing. Just click on this. Okay, and then here, so you can minimize the report a bit, and from here, as you can see, you have let's say all the necessary information. For example, you have the information about the section, about the material. Here you have the information about the buckling or lateral torsional buckling, and also here you have the symbols or explanation about the equations. And after that, so here you have the code with the clauses, and from here also you can just a little bit go down, and here you have a very nice a report. For example, here it is for crushing of the web induced by the compressed flange, and the following criteria must be satisfied. So every equation in detail is written here, and you can simply if you want to cross check or double check by yourself, so it's very easy to do that because everything is here is a very transparent way. Okay, so it is for the report, and so if you want to create the report, so here you have the option. Sorry, here you have the report, and then so from here you can customize your report as well. I'm not going actually now to create the report here, but for your general information, so you can actually also take a look at this report option as well. So since here we have lots of members, and that's why, so maybe a little bit you can wait, and then here you have the options, and you can actually customize your report. For example, if you want to just have the bill of quantity. So you can uncheck all the options, and then here you have the under structure. Here you have the quantity table, and also you have the quantity summary. For example, here I want to report the quantity summary, and then simply I can select that one and accept, and here the software automatically generate the quantity summary for me. So here you have it. Okay, for example, how many UC section I have, how many UB section I have with different sections, and also the SHS IPE, including the for example the volume, the length, the weight. So everything is there. Okay, so it is actually for report. So please stay tuned with us. So in the next video also we will talk about the generating the report, and also the drawing, and also other features that you have in CYPE 3D. But for this series of design of portal frame, so here it is the last video, and so we can finalize this series from part 1 to part 6, which is this part. And so hopefully you enjoy, and again, please stay tuned with us for next coming videos, and please share our videos with your friends, with your colleagues, and just to encourage us to generate more informative videos. Thank you so much, everybody, and have a great day.